Hello everyone, greetings to all the audience. My name is Mesut Durukal. I'm a quality assurance engineer and I'm doing testing activities on daily basis. I have worked in lots of different domains in lots of different projects, including defense industry, cloud platforms, IoT devices, autonomous mobile robots, and web applications. And quickly overviewing all this time, I have done lots of different testing activities, including the functional testing, environmental testing, non-functional testing, and all these things in lots of different ways. Previously, I was doing mostly manual testing, but nowadays, of course, more automated testing. And we have tried lots of different approaches, including shifting left, shifting right, continuous testing, DevOps adaptation, and we have transformed our projects from waterfall to agile practices. And still, we are trying lots of different novel approaches. For example, we are trying to adapt more machine learning algorithms into our software testing applications to improve the efficiency and the productivity in our projects and the activities, because we are trying to reduce the manual effort needed and time for execution and implementation needed to complete our activities. So software testing has been evolving a lot. It has changed. The way that we are doing and what and how we are doing things has changed a lot. But only one thing did not change at all, which is why we are doing this. Of course, our biggest and the first concern is quality. So whatever we are doing or in what ways we are doing, we are trying to ensure the quality. So we are trying to improve the confidence on our product and the quality in the product that we are developing. So in the session, we will talk about in what ways we can improve the quality of our product and indirectly maybe trying to improve the quality in our processes to build those products. So this is a usual software testing lifecycle, starting from the analysis of the requirements or analysis of the system under test. And we will investigate what we can do to improve our processes in each stage. So let's start with the first one, which is the requirement analysis or the analysis of the system under test. So in this stage, we can of course improve our feature management processes and approaches, because sometimes the features that we are developing or we have already developed are clear to someone, but there are some ambiguous points. For example, everyone has a basic understanding of the features. For example, what the customers should expect after navigating to this page or after clicking this button. What is the expected behavior? This kind of a basic understanding, of course, is clear for everyone. But sometimes in corner cases or some detailed use scenarios, there are some ambiguous points. It is not very clear. It is not documented well. So you have to figure out what is the expected situation after each these kind of corner cases. Why am I saying that some features may not be very well documented sometimes? Because in Agile, the working product is more important than the comprehensive documentation. But of course, we have to interpret this in the correct way. Because it doesn't mean that we don't need any documentation at all. And while trying to implement the correct and accurate product, if we all forget about the documentation, then we may have some points which is not clear to everyone. So one of the very first initiatives that I tried in my project is to sit together with the product owners and the product managers and go over all the features. So in this way, if there is any points which is understood in different ways by different people, then we try to do build a basic understanding and pull everyone on the same page. And in this way, we would avoid the misunderstanding, and we try to clarify all the expected behaviors on each specification. And not only this, and we had another advantage, which is the removal of obsolete features, because after some time, you will realize that some end users or the customers are not using all the features that you implemented, because there are some specifications mostly used by the end users. But of course, you included some features and there are some more specifications, but maybe they are not used by the customers at all. So we don't have to maintain them in production. So in this way, we can reduce the maintenance effort by revealing the obsolete features which are not used by the end users, and then we can improve the efficiency and reduce the maintenance in our products. And one more thing we can do in the system analysis phase is encouraging the QA involvement in the early stages, because most of the time I hear lots of different complaints like they change the behaviors and my test is broken by the testers. Why? Because they update the behaviors. So it is not the previous behavior. It has changed and it is updated by the developers or the product owners. And it is very normal, right? Because in Agile, we should be open and we should be welcoming the changes, change requests. But what is the missing point here? Whenever those changes or updates are planned, the QA members or the quality assurance team should be notified. This change is planned, so please in the meantime prepare your or start your test preparations. Otherwise the test would be already broken because they would not be kept up to date and they would not be covering the correct scope anymore. The expected behavior or the actual behavior is not same anymore, but our test case is still trying to assert the previous behaviors. So there will be a misalignment in this way. So what we can do is try to encourage QA involvement in the early stages, even while designing the expectations or the specifications. In this way, even in the first place, we can discuss about the testability of the requirements, right? Or even in the first place, if we see any usability issues, we can raise our voice and even before starting the implementation, we can already reveal some improvement rooms. So what we have done in our project is we agreed with the development teams, and whenever they create some tasks, they create some relevant subtasks, including the relevant testing activities, and assign to the QA teams. And in this way, whenever they create a development activity, whenever they create a task for the development activities, the QA teams were notified and they were aware what was being developed and implemented in the development teams. After the requirement analysis, the second phase or the second ring in the whole software testing chain is the test design. So it is very important because even if we know the requirements or the specifications of the system very well, if we don't have the accurate test steps to cover them in the proper way, then maybe we will overlook some issues because in some use scenarios there may be some issues or bugs in the product. And if we are not covering correctly with our test steps or test cases, then maybe we will have them in production environment because we will not be able to catching them in time. So we will have them in the later stages. So maybe they will be reported from the customers in production environment. So it will be much more costly and expensive to fix those issues in production after we deploy them. So designing test cases and defining all the test steps in the correct way is very important. So let's discuss in what ways we can improve our test coverage and test design techniques. The very first thing that we should keep in mind is customers will try always the unexpected flaws. For example, if there's any negative scenario, they will try them. There's a famous quote, very well known in testing industry is, if there's a zero in the system, then someone will try to divide some numbers by zero. So it is not a positive scenario. Of course, it's a negative scenario, but we should try to cover this with our negative test cases, because otherwise maybe it will be a fatal error. So it will be a critical impact if this case is performed by the users. And there is one more paradox very well known by testers, which is the pesticide paradox. So if we try to test all the time the same scenarios, then of course it will be not a high possibility to find bugs from these test cases after some time, because we should try something different. Because if we always run the same test cases, and then we will not be finding any more bugs after some time because they will be fixed. And if we repeat the same test cases, then maybe after some time the likeliness or the possibility to find bugs will not be that much high, because infinite testing is not possible. So we should pick the test cases, the most prior test cases, and the high criticality or the test cases which with the high impact. And of course, while doing this, selecting our subsets, sometimes we have to pick some different test cases from different use scenarios. So the very first thing that maybe we should keep in mind is try the unexpected scenarios to avoid the critical issues, the fatal issues, and try to improve our coverage rather than executing always the same scenario, try to improve the coverage by including lots of different test cases. And if we do not include the correct coverage, maybe again we will be overlooking some issues, because the product is always being updated by the developers. There are always some new features, and if we do not select the correct subset, maybe some more features which were recently added are breaking the product. But if we are not covering them correctly, then maybe we will be overlooking some issues introduced to the system by adding these features. So we are talking about improving the coverage, but in what ways we can improve them? So we can embrace lots of different test design techniques, and we can try them. For example, there are lots of different techniques we can use, but of course a few of very well-known ones is maybe the equivalence partitioning. In this way we can try lots of different data values, not only a certain range of data, but also lots of different ranges. Or maybe the boundary value analysis, to figure out if the boundary values, like the minimum limit or the maximum limit, or the values around those limits, are breaking the system or not. Or of course we can do the exploratory testing, and lots of different test design techniques we can embrace. So eventually the main purpose should be covering the correct steps or the use scenarios which will be performed by the end users. And one more thing we can do after designing our test cases is, of course, generating some documentation revealing the coverage. For example, if we map the features to the test cases, then we can understand which features are tested by which scenarios or which cases. Or we can easily see that if there is any feature which is not covered by any test case. So if we build these kind of traceability matrices by mapping use cases or scenarios or the specifications by the test cases, then we can reveal our coverage gaps. And most probably our coverage gaps would be stemming from the testability issues. Because why don't we have some test cases covering those specifications? If we did not forget to create some test cases, then most probably we were not able to create those test scenarios, because there were some testability issues. This is the very high likely the reason for the coverage gaps. So testability issues are very important in terms of coverage. So I wanted to emphasize a few examples in terms of testability. What kind of testability issues we may have? For example, if we are testing a subsystem, and if we have some dependencies, like there is any data transfer from any other subsystem, the service is pulling some data from another service. Like if we are testing the front end, and if the data is coming from the backend services, and if we don't have the full control on the backend services, then maybe we would not be able to triggering some scenarios. For example, if there's a new data in the system, in the database, then it should show up in the front-end modules, right? Let's say this is our expected scenario or the expected behavior. So to test this, first of all, we have to introduce a new data, and then we should observe if it is showing up in the front-end pages. But if we don't have the access rights to create a new data, then we would not be able to simulate this scenario. So having the correct or the enough access rights, or having the correct control on each of the modules or components of the system is very important. Otherwise, we may have some testability issues. The next stage is the test implementation. Nowadays, we are mostly doing the test automation, and we are trying to automate our test cases to be able to execute them automatically in our pipelines. Because we are doing continuous testing, continuous integration, every day we are having lots of different deployments and integrations. So in order to ensure that these changes or commits or pushes, merges do not break anything, of course, we have to execute our test cases after or before, even before each merge. So to be able to do this, of course, manual testing is not enough. We have to have some automated test cases, and in this way we can execute them on our pipelines. So they can be triggered after each commit, and before merging to production environment, we can execute them, or we can schedule some tasks. So by timely jobs, we can execute our test cases. So this doesn't mean that, of course, we don't need manual testing anymore, because automated testing can cover a certain scope of the product. But of course, we should always support our test activities by manual testing. But still, one of the very basic activities that we are doing in daily basis is the implementing the test cases and test automation. And since we are talking about continuous testing, the reliability or the stability of the test is very important, because we will execute them a lot of times, and if they are sometimes failing, sometimes passing, if they are not stable, then we will have to have a lot of maintenance and analysis efforts. So let's start talking about different quality aspects of the test code that we are developing. So of course, again, it is not only functionality, but of course there are lots of different aspects of the test code quality. For example, the maintainability, the understandability, reliability, robustness, efficiency, portability, scalability. There are lots of different aspects of quality. So we should keep in mind lots of different dimensions of the quality while implementing our test code. And we will discuss why they are important. Let's start with the reliability aspect. So if the features that are developed are working well, which means they are working as expected and they are working aligned with the expectations or the requirements. But in this case, if our test cases are failing, and if they are reporting some failures, then it means they are reporting a bug, they are reporting a failure, but normally the feature is working well. So it is not a real bug, it is a false alarm. So in this case, we would need some extra analysis effort. We have to understand if the reported failure is a real bug or a false alarm. So it will be some waste of time. On the other hand, if the feature is not working well, which means is not working as expected, but our test case is not failing, in this case it is not reporting a bug or it is not reporting a failure, then in this case it means we will have a silent horror case, because there is a vulnerability, there is an issue in the product, in the feature, but our test case is just passing. So we will not be aware of this issue, and maybe we will let the release candidate to go in production, and we will have the issue in production. So we will miss the issue, we will have some escape bugs. So these kind of reliability issues are resulting in some critical issues. On the one hand, it will be some extra maintenance or analysis efforts. On the other hand, maybe we will have some escape bugs. So these are the issues stemming from reliability weaknesses in the test code that we are developing. But why can we have some reliability issues in our test automation frameworks? So the main reason for these reliability issues are the test smells. As the code smells while developing the product code, similarly we may have some test smells while we are developing our test automation framework. So there are lots of different dozens types of test smells there are in the literature, but maybe the very well known are the flaky test cases, which are sometimes passing, sometimes failing due to lots of different reasons. But the most commonly known reason for the flaky test or the flakiness is the timing issues. For example, if we are dealing with some asynchronous services or microservices working independently from each other, so when we perform a request, so your request will be responded by a maybe successful response, but it doesn't mean that the whole transaction is already completed. So maybe the rest of the operations are still being performed in the remaining backend services. So after having the first successful response, if you immediately check for the expected result, maybe it is not there yet after you just sent the assertion. But instead, rather than immediately sending the assertion, what we can do is maybe we can adapt some polling mechanisms, like until the maximum acceptable duration, we can periodically check if the expected condition or the expected response is already there or not. If not, rather than failing the test case, we can check one more time, because we will not be sure when the whole transaction will be completed in the backend services due to the asynchronous structure of the product. Not only the flakiness, but we may have lots of different test smells, like maybe some test cases can be fragile. When we change the test inputs, they would start failing. So it means that they are not robust against the test inputs and or the test parameters. So we should improve the robustness or the stability of those test cases against the test inputs. And we may have some dependency issues, execution dependencies, because sometimes we are not testing the test cases standalone. Sometimes we are putting them into different suites and running them with lots of different test cases. So if we have some conflicts, and if one of the test cases make the other one failing, then it means we will have some dependency issues. So we should get rid of all these kind of issues. And we may have some structure issues, assertion issues. Maybe we are not asserting the same thing. Like it sounds very trivial, but sometimes we may put assert true. And even if you put some conditions inside, then if since you are always asserting the true condition, the test will not fail anytime. So all these kind of test smells we should be aware of, and we should cope with this kind of reliability issues. And of course, the way to improve the reliability or the accuracy of our test cases is to have some strong quality gates. Because whenever we implement some test codes, rather than immediately merging them in production, first of all, we have to check very well if the quality is in the expected level or not. And for this purpose, of course, we can integrate some static code analysis tools, and we can use linters or maybe some tools like SonarCube to define some quality metrics and quality checks, and we can observe if the developed code is meeting these checks or rules or not. Not only the static code analysis tools, but also we can do the peer review activities. And after we implement our test code, we can share to another colleague in the team to collect some feedback. And thanks to this kind of peer review activities, we can improve the quality in our test code. And before merging into our test automation framework, we can improve our quality gates and do some checks by thanks to the static code analysis tools or the peer reviews. And one more aspect in addition to the reliability is the maintainability. It means after our test cases are broken, then how easily can we fix them? Because sometimes we are doing the API testing, and sometimes we are doing the UI testing, which is the UI automation and the front-end automation. So especially for the second part, test may be easily broken because sometimes the pages or the layout of the pages are updated by the developers. And normally for doing the UI automation, first of all, we have to locate the elements on the page, and we use different locators to find or locate the elements on the page. We can use their class names or paths or different attributes of the elements. And if somehow after this layout changes, if the locator is not working anymore, if the element doesn't have the same class name or the same path anymore, then the locator would not work and our test case would be broken. So how easily our test is broken, or after it is broken, how easily we can fix them. This is the maintainability aspect of the quality of our test automation framework. And one initiative that we have done in our project to improve the maintainability is, rather than using the class names or the class paths, we added some unique IDs to all the elements, and we made an agreement with the development team. And whenever they were implementing or introducing a new element to the pages, they were adding the unique IDs. So in this way, I was not using the class paths or the class names, but I was using this ID to locate the element. And even if they changed the layout of the page or the attributes of the elements, then I was still be able to find the element because the unique ID was still there, and my test cases were not broken anymore. So this is why we are saying always quality is not something which can be performed individually, but it should be a team effort. So we should perform lots of different initiatives which can be performed by a collaboration with the other teams. First of all, maybe we can sit together with the product owners or the product managers, and we can discuss about the features, the improvements on the feature management processes, and then we can sit together with the development teams to reveal the testability issues and how we can get rid of those testability issues. Maybe we will be requesting from them to implement some additional interfaces, right? Because if some data is not visible to me in the front-end module, then maybe I would be asking them to implement some additional public APIs or other interfaces to be able to see those data that I need. I know that it will not be used in the production environment. It is not needed by the end users, but just for testing purposes, maybe I can ask these kind of additional implementations from the development team. And in this case, just to improve the maintainability, I asked them to add some unique IDs. And thanks to this collaboration, the test maintenance effort was reduced in a significant context. And the next stage after the test implementation is the test execution. So after we implement, now we are ready to execute them in automated ways in our pipelines. So before merging the implemented increment into the production, first of all, we can execute our test cases. And then if we find any issues, we can fix. And eventually, if we decide that the candidate is ready to go production, then we can let it go and release to the production environment. But first of all, I want to talk about the importance of the test activities in all levels, because it is not only the system level, but also it starts from the unit level testing. And then after we implement and execute some test cases in unit level, then we can execute integration tests. And finally, we can do the test activities in the system level. Maybe we can execute the E2E, end-to-end test scenarios or the use scenarios to ensure the quality. Because if any of them is missing, maybe we will not have the accurate efficiency. And if we are lacking the unit test or the integration test, we would require too much time to execute our system level testing. If we are trying to cover most of the cases in system level, it will not be efficient and it will not be feasible because we don't have too much time. Normally, the unit tests are way faster than the E2E tests because they are done on the independent modules and they are cheap to execute. We don't need too much resources to complete these kind of test cases. So maybe what we can do is we can balance the load on different levels accurately, and most of the scope can be covered by unit tests, and gradually we can execute the other levels. And if we only execute the unit test but not integration tests, then maybe some modules will be working accurately, but they will not be working accurately together. So not only the unit test, but also the integration test and the system level tests are very important. And a little bit more focusing in the system level testing, we can try to improve the quality in lots of different ways. Reusability is a great way to improve the efficiency and the quality in our test automation framework. Because if we have some duplication, it will be much more maintenance effort or the analysis effort after the failures. So one practical example that I tried to do in my project is, after I realized that some tests were duplicated, I tried to exclude all the configurational variables from the test code itself, and I managed those environmental variables as configurations, and I implement only one test case to execute in lots of different configurations. For example, in this example, I'm testing a job seeking platform in which there are lots of different web applications. So users can go to different websites serving to different locations or regions. For example, in Asia there is another website, in Europe there is one more another website, and there are lots of different web applications that I am supposed to test. So to do that, normally the end users are going to these websites or the web apps and doing some queries to find or seek for some jobs. They can put some keywords like the job title, like QA automation engineer or anything else, and they can put the location, and then they can perform the query. So this very simple use scenario can be executed on all the apps. So this is a common test scenario for me. I don't have to duplicate all the test cases for each website. So what I can do is I can implement only one test case covering this scenario, and I can execute on all sites by changing the environmental variables. For example, if I introduce the app name under test, then I can dynamically generate the URL to be navigated, or I can change the browser in which I want to execute the application, or even the platform like the desktop or the mobile version, or the stage in which I want to execute, like the QA stage or the prod stage, I can change lots of different configuration variables. In this way, I can remove all the duplication, and I can execute only one test case in lots of different configurations by managing these environmental variables in a proper way. And one more thing that we can do is, of course, to decide about the test suites, because as we discussed before, we don't have too much time to execute all the test cases in each our activity. For example, if we are running the regression testing, then we have to pick the relevant test cases, because testing all the or running all the test cases that we have is not feasible or efficient way, because we don't have that much wide testing windows. We have a very limited time, and we have to select the relevant test cases to be efficient enough to complete our testing activities. And maybe if we have some nightly jobs or any other jobs, we can run a wider scope. But if we want to run all the test cases before each merge, then it will be blocking the development activities, because it will take too much time, and the developers will be starting complaining about the duration of the test cases. So what we can do is we can decide about the priorities of the test cases, and relevantly we can generate some different test suites with different scopes. So this is one more initiative that we have tried in our project. To decide about the priorities, we take two dimensions into consideration. The first one is the criticality of the issue. If the issue happens, how critical it will be, or what kind of impact it will have. This was the first dimension. And the second dimension, or the second aspect that we take into consideration, was the likeliness or the probability of the issue. For example, even if it is a very critical issue, maybe it will be barely happening in production, because maybe the likenesses or the likeliness or the probability of the issue is very low. So merging these two different aspects, we were deciding about the priorities, and we went through all the test cases together with the development leads or the product managers, and we considered both the criticality and the visibility to the end users, because in that case mostly the product managers are familiar with the visibility of these issues in production environment or the end users environments. And eventually we decided about the priorities and our test suites. And the last ring in the whole chain is the continuous improvement. Normally, we complete our test implementation, we complete our execution, and finally, if we find some issues, we report them. And if any of the test cases is broken, we try to maintain them and we try to fix them. And again, in this stage, we may have lots of different initiatives to improve the quality of our processes and eventually the quality of our products. So let's investigate what we can do in this stage. First of all, we can improve the robustness of the test case after doing some comprehensive analysis. And what is the way to do this comprehensive analysis? Of course, first of all, we should be able to see all the test results. It should be visible, and all the executions should be transparent enough to make a comprehensive analysis. Because not only the last execution, but also with a detailed test history, I can see all the results, and I can observe in which execution or in which instance the test failed and in which others it passed. So I can see how frequently it is failing or how flaky it is. And after this kind of analysis, and after doing the root cause analysis, after I understand what is the root cause for, or what is the root reason for this failure, then I can try to one by one get rid of all these kind of root causes for the flakiness. And of course, timing and the efficiency to execute the test cases is one more important thing. So we don't want to block the merges. If we are spending hours or even minutes before each merge, then it will not be efficient, right? So we may try to reduce the time as much as possible. So what are the ways to reduce the execution time? If individually inside the test cases, if we have some dummy weights, of course we can get rid of them, because normally, ideally, we don't need any dummy weight inside the test code. If we are looking or waiting for something else, then we can add some smart weights. And if the condition is already there, then we don't have to wait anymore. We can continue on or proceed with the next steps. And apart from this, of course, we can add some parallelization to our executions on the pipelines. We can create lots of different virtual instances or virtual machines, and then we can divide the execution into different instances, into different set of instances. So not only one machine, but also if we are using a number of virtual machines, then we can parallelly start different scope of the whole set into different machines, and then in this way it will be much more shorter execution duration to complete the test cases. And eventually what we can do is to collect some metrics from the production environment to get some insights about the satisfaction of the customers. For example, if they are using a lot of failures or downtimes in production, sometimes if the pages are not responding to the customer queries or the end user queries, then we can observe by collecting these metrics. For example, we can measure the response times, or we can collect lots of different metrics from production environment, and then we can do some analysis to understand what kind of struggles the end users have, or what kind of aspects or the attributes, or what kind of quality features we may want to improve in the future after doing these analysis. So doing the continuous monitoring activities is one more initiative that we can do to understand the improvement rooms that we can perform and to apply in our products and projects. So wrapping up, we went through lots of different stages in the software testing lifecycle. It is not happening once as in the waterfall approaches, but it is happening in an iterative way. We are always analyzing the new features, and once we have the feature which is planned to be implemented and deployed or released in production, first of all, we understand all the aspects very well, because otherwise, if we don't know the system that we would test, maybe we will overlook some use scenarios. First of all, we have to understand it very well. We have to know the system very well, and then we have to cover this with the correct test coverage. We may use some different test design techniques to design our test cases in the accurate way, and then we can implement test cases. And of course, in terms of implementation, if we are doing the test automation, the test code, the quality in the test code and test automation framework is very important. Otherwise, we may have some reliability issues or the maintainability issues. And while executing, of course, we can do lots of different initiatives to reduce time and improve the efficiency. And finally, we have the continuous improvement stages in which we can manage our executions and we can do the efficient completion of our testing activities. So last but not least, quality is something that should be embraced by everyone in the team, everyone in the organization. Because if only certain people is trying to complete the quality goals or the quality related tasks, then maybe we will not be successful to achieve these quality goals, because we have to do a teamwork. Otherwise, if everyone is not contributing in the same goal, if everyone is not having the same mindsets, then we will not. It is not possible to complete the quality achievements. So, last but not least, quality is not something which can be performed by some individuals, but it should be a teamwork. It should be a holistic approach, and eventually we can embrace our quality goals and we can always have the same quality mindset. So thanks for listening, and please keep always quality in mind.